When you make a phone call, stream a YouTube video, or connect to Wi-Fi, an incredible amount of signal processing happens behind the scenes. But despite the complexity of modern communication systems, they can all be represented using a surprisingly simple block diagram. Understanding this diagram is one of the most important steps toward becoming an RF engineer. In the previous lesson, we learned that a communication system transfers information from a source to a destination. While this sounds simple, real communication systems contain many components working together to make reliable communication possible. Consider a smartphone call. Your voice must be converted into electrical signals, processed, transmitted through the air, received by another device, and reconstructed into sound. Along the way, the signal encounters noise, attenuation, interference, and various hardware limitations. This raises an important question. How do engineers organize such complex systems? To understand and design communication systems efficiently, engineers use a simplified representation known as the RF system block diagram. An RF system block diagram is a simplified representation of the major functional blocks involved in transmitting information from a source to a destination. Although real systems vary in complexity, most RF communication systems follow the same basic structure. Information source transmitter channel, receiver destination. The information source generates the message. The transmitter converts that message into a form suitable for transmission. The channel carries the signal between locations. The receiver extracts the information from the received signal. Finally, the destination receives and uses the recovered information. This block diagram approach allows engineers to analyze each section independently while still understanding the behavior of the complete system. Intuitively, the RF system block diagram can be compared to a package delivery service. A sender prepares a package, a transportation network carries it across a distance, and the recipient receives and opens it. Each stage has a specific purpose within the overall delivery process. Physically, consider a mobile phone call. Your voice serves as the information source. The smartphone transmitter converts voice into an RF signal. The electromagnetic wave travels through the air, which acts as the communication channel. The receiving phone captures the signal and reconstructs the original voice, delivering it to the listener. Mathematically, each block transforms the signal in some way. The transmitter prepares it for propagation, the channel modifies it through attenuation and noise, and the receiver attempts to recover the original information as accurately as possible. The RF system block diagram serves as the foundation for nearly every communication technology. Cellular networks, Wi-Fi systems, satellite communications, Bluetooth devices, GPS receivers, and radio broadcasting systems all follow this same general architecture. RF engineers often specialize in specific blocks within the diagram. Some focus on transmitter design, including power amplifiers and modulators. Others work on receivers, signal processing algorithms, antennas, or channel analysis. Regardless of specialization, every engineer must understand how all blocks interact within the complete system. At the system level, performance depends not only on individual components, but also on how effectively the blocks work together. A highly advanced transmitter is of little value if the receiver cannot recover the information accurately. The RF system block diagram provides a roadmap for understanding communication engineering. Nearly every concept studied in future RF courses, including modulation, coding, antennas, noise analysis, and wireless propagation, fits somewhere within this framework. A common misconception is that communication systems are primarily hardware systems. In reality, information processing is equally important. The purpose of every block is not simply to generate signals, but to preserve information throughout the communication process. Now that we understand the overall structure of a communication system, we can begin examining its major components individually. In the next lesson, we will compare the transmitter and receiver and discover how these two critical blocks perform very different but complementary functions. In this lesson, we learned that the RF system block diagram provides a simplified view of how information moves through a communication system. We explored the major blocks information source, transmitter, channel, receiver, and destination, and saw how each contributes to reliable communication. In the next lesson, we will compare the transmitter and receiver and discover how they work together to move information across a communication channel. If you found this useful, like the video, subscribe, and follow for the next lesson.